So here we have our 11.2 notes, also known as two sample stuff, also known as navigate the greenie. I'll let you people read the problem, but what we have here is two distinct samples, control group and experimental group. I took the liberty of putting the data in my calculator, and since we're doing two variable statistics, two samples, I pushed two variable statistics and got an X bar of 4.875, a standard deviation of 0.1642. My second X bar was 3.0125, and my second standard deviation is 0.1727. Make sure you can push the buttons on this, and you got to scroll down to see those numbers. Degrees of freedom. 8 in this group, 8 in this group, so 8 minus 1 is 7 for both. Looking in the back of my book. 90 degrees, scrolling up, 90%, excuse me, scrolling up to 7 degrees of freedom. 1.895 is my T star. Here's the standard deviation formula. Oh no, how am I ever going to remember that? Probably straight off the greenie. We need to navigate the greenie now. Since I'm doing a confidence interval, I'm doing my statistic, which is the difference between our two X bars, plus or minus the critical value, which is the T star, plus or minus the standard deviation. So we just need to know which standard deviation formula to use. The square root of 1.642 squared over 8 plus 1.727 squared over 8. It's right here in front of you, but I would push the buttons to make sure I can get this confidence interval of 1.075, the difference between my X bars, plus or minus my T star times the standard deviation is 0.160. If you would rather, from 0.915 to 1.235. Two distinct samples. We'll talk more about our conditions, but both of our samples need to be SRSs of the population of plants for the problem we're talking about. Standard deviation formula, go conservative in room 215, at least with degrees of freedom. I'm going to show you a significance test out of the book here now in just a second. Here is our null hypothesis. Here is our alternate hypothesis. Fourth verse, same as the first. Here's a confidence interval, something plus or minus something times the standard deviation. Here's a significant test, stat minus parameter over a standard deviation of the stat. This confuses people sometimes because our authors don't put it in, but if the null hypothesis is mu1 equals mu2, that is the same as saying mu1 minus mu2 equals 0. Statistic minus parameter over the standard deviation of the statistic. Here's a quick problem. Problem 9 on page 626, talking about social insight of males and females. Null hypothesis, is that they are the same? Yeah, right. Social insight of males and females are the same. Alternate hypothesis is that they are not equal. Myself, I would say mu1 is less than mu2, mu1 being the males, but I'm going to stick with the book here. Take both x bars, put them here. I would say this minus 24.94 minus the null hypothesis is that the difference is 0. It all works out the same. First standard deviation divided by n. Second standard deviation, whoops, don't forget your squared, divided by n. Find the t-score, and after that, it's just like with the one sample. Once you have a t-score or a z-score, you can find your p-value. If it's low, reject h sub o. If you go and look on the next page here, the p-value is actually high, so we would not reject h sub o. Once again, I disagree. There's no way that males have the same social insight as females, but I'm going to have to go against the book here. Here's the greenie. Make sure you can navigate it and know which standard deviation formula to use. With two samples, two sample means, you're using this one. With one sample mean, you're using this one. It's all about navigating the greenie. Here's my pink out again. You can pause it and rewatch the video if you need to fill in the blanks there. We'll fill in another blank here another day. Stop.